procedure to be a binomial, it must have these four requirements. First, the procedure must have a fixed number of trials. Second, the trials must be independent. Third, each trial must have only two outcomes. Hence, binomial. Bi means two, so two outcomes. We classify them as success and failure. And fourth, the probability of a success remains the same. Now, some notations. P is the probability of a success. Q is the probability of a failure. Note, Q plus P equal 1. Why? Because the sum of all probabilities must equal 1, and in this case we only have two outcomes. And so Q then can be computed by taking P away from 1. Now, N represents the fixed number of trials. X represents the number of successes in N trials. Now, this P of X represents the probability of getting exactly X successes among the N trials. Now, let's look at the formula for a binomial probability. Okay, so this is the formula for the probability of getting exactly X successes. Okay, this is only the formula for getting exactly X successes. Once again, these are the notations that we just talked about. Let's look at an example. When an adult is selected with replacements, there is a 0.85 probability that this person knows what Google is. Use the binomial formula to find the probability that when 5 adults are selected, exactly 3 of them know what Google is. Now, we want to make sure that this is a binomial probability distribution. And so it is a procedure that is a binomial distribution because first we have a fixed number of trials. Now, before we can answer this question, we want we wanted to make sure that we have a binomial distribution. And we said that we do because we selected 5 adults. So n equal 5. We have fixed number of trials. Second, each trials are dependent because the probability of any adults knowing what Google is not affected by the results of any other adults. Third, each person, either they know or they don't know, either they know or they don't know what Google is, and so we have 2 outcomes. And the fact that there is a 0.5 probability, that probability remains the same for each person. And so we have a binomial distribution. Now let's talk about some notations. Okay, so now n is 5 because we selected 5 people. X is 3 because we want to know exactly 3 people out of those 5 if they know what Google is. If they know what Google is, right? Third, we know that P is 0.85 because we're told that there is a 0.85 probability that this person knows what Google is. And if 0.85 is the probability that a person knows what Google is, then Q must be 0.15 because Q is 1 minus P, and we're told that P is 0.85, and so 1 minus 0.85 is 0.15. Now, if you think about it, if 0.85 is the probability that a person knows what Google is, then if that person does not know what Google is, right? If the person does not know what Google is, then it must be 0.15. Now we have all the numbers that we need. N equal 5, X equal 3, P equal 0.85, Q equal 0.15. We now plug it in into the formula. Remember this formula? Right here. N is 5, okay. X is 3, P is 0.85, and Q is 0.15. And so when we plug it in into the equation, we now have P of 3 equal 0.138. Here I'm just take up the 3 decimal digits. Okay, you can confirm this by using your calculator. And so 0.18, actually 0.138 is the probability of getting exactly 3 adults who know what Google is. Now, with a binomial distribution, we can now compute the mean, the variance, and the standard deviation. Okay, the mean is pretty easy. It's just simply n times p. The variance, or sigma square, is n times p times q. If you take the square roots of the sigma square, you get the sigma, and that's how we get the standard deviation. So the standard deviation for this case is the square root of n times p times q. Now let's look at an example. In NFL football games, there are 460 overtime wins with P equal 0.5 and Q equal 0.5. Here we're assuming that both teams have the same chance of winning the game. We want to know the mean and the standard deviation for the number of wins in groups of 460 games. Okay, so we're told then the total games is 460, so n is for 60. We know a p, we know a q. We now can plug it into a formula to get the mean. So the mean is n times p. So 460 times 0.5 is 230. Sigma, or the standard deviation, is the square root of m times p times q, and so it is equal to the square root of 460 0.5 times 0.5. It is 10.7 games. And so for this example, we have the mean of 230 games and the standard deviation of 10.7 games.